Welcome to Network Professionals. Hello everyone. Welcome back to our channel Network Professionals. I'm engineer Javiria Oftab, CISCO certified instructor. In the last lecture, we discussed Chapter 4, in which we briefly looked at preventive maintenance and troubleshooting. In this lecture, we will move on to Chapter 5, where we will discuss networking concepts. So, let's begin. Chapter 5 Sections and Objectives. Network Components and Types. Explain components and types of computer networks. Describe the types of networks. Describe internet connection types, network protocols, standards, and services. Explain networking protocols, standards, and services. Explain the purpose and characteristics of transport layer protocols. Explain the significance of application port numbers. Explain wireless protocols. Explain network services. Network devices. Explain the purpose of devices on a network. Explain basic network devices. Explain security devices. Explain other network devices. Network cables. Explain the characteristics of network cables. Describe networking tools and their purpose. Explain the purpose and characteristics of common types of copper network cables and connectors. Explain the purpose and characteristics of common types of fiber network cables and connectors. Our first topic is network components and types. Types of networks. Network icons. Types of networks and network icons. Discussion. When learning about types of networks, it's also important to understand how different components are visually represented using network icons. These icons help describe the structure and elements of a network in diagrams or maps. Intermediary device icons. These icons represent devices that connect and manage traffic within the network. Examples include routers, switches, and wireless access points. They help direct data between devices and ensure efficient communication. Network media icons. These icons illustrate the transmission medium used in a network, such as Ethernet cables, fiber optics, or wireless signals. They show how devices are physically or wirelessly connected. Host device icons. Host devices are the end-user devices in a network, like computers, laptops, servers, and smartphones. These icons represent the devices that send and receive data over the network. Understanding these icons helps in visualizing the components involved in different types of networks such as LAN, WAN, and WLAN, and how they interact with one another. Network topologies and description. Types of networks: PAN, LAN, VLAN, WLAN. When discussing networking concepts, it's essential to understand the different types of networks based on their size, structure, and use case. Here's a brief discussion of some common types. PAN, Personal Area Network. A PAN is the smallest type of network, typically used for connecting personal devices within a short range, usually a few meters. It commonly uses Bluetooth technology to connect mice, keyboards, smartphones, tablets, and wireless headphones. This network is centered around an individual and their devices. LAN, Local Area Network. A LAN connects multiple devices within a limited geographical area, such as a home, office, or school. It usually involves wired connections through switches and routers. LANs are known for high speed and reliability and are commonly used in small to medium-sized organizations. VLAN, Virtual LAN. A VLAN is a more flexible version of a traditional LAN. It allows network administrators to group users and devices logically instead of physically, for example, by department, role, or floor within a building. Even if users are in different physical locations, they can be on the same virtual network, improving organization and security. WLAN, Wireless LAN. A WLAN uses wireless technology, Wi-Fi, to connect multiple devices to the network through an access point. It provides the same functionality as a LAN but allows for mobility and flexibility, making it ideal for homes, offices, and public areas like cafes or airports. These different types of networks serve various purposes depending on the environment and the needs of the users. Types of networks: WMN, MAN, WAN, VPN. As networks grow beyond small areas and become more complex, additional types of networks are used to meet different needs. Here's a discussion of some broader and more advanced network types. WMN, Wireless Mesh Network. A WMN is a type of wireless network where multiple wireless access points are interconnected to expand coverage and improve reliability. In a mesh setup, each access point, node, communicates with the others, creating a web-like structure. This is useful in areas where a single access point cannot cover the entire space, such as large campuses or outdoor venues. MAN, Metropolitan Area Network. A MAN covers a city or metropolitan area, connecting multiple buildings, offices, or campuses. It is larger than a LAN but smaller than a WAN. MANs are commonly used by governments, universities, or large businesses to connect their branches across a city. WAN, Wide Area Network. A WAN spans a large geographical area, often covering countries or continents. The Internet is the most well-known example of a WAN. It connects multiple LANs and MANs through public or private transmission systems. WANs are essential for global communication and data transfer between far-off locations. VPN, Virtual Private Network. A VPN allows secure communication over an unsecure or public network, such as the Internet. It creates an encrypted tunnel between the user's device and the destination network, such as a company's internal network. VPNs are widely used by remote workers or travelers to safely access resources from outside their organization's physical network. These network types play a crucial role in connecting people, devices, and locations, whether locally or globally, with security and scalability in mind. VLANs. They provide segmentation and organizational flexibility in a switched network. A group of devices within a versus LAN communicate as if each device was attached to the same switch. VLANs are based on logical connections, instead of physical connections, and they can be segmented based on factors such as function, team, or application. For example, a faculty member computer, PC1, is connected to S2 on VLAN 10. PC1 could communicate with another faculty member using PC4 connected to S3. Notice how both hosts are configured on network address 192.168.10.0/24. By default, all switch ports are assigned to VLAN 1. However, you can assign the PCs to different VLANs by configuring their interconnecting port. Figure 2 displays a sample configuration of switch S2. Notice that we first create the VLANs and assign them names. This makes it easier to work with the VLANs. Next, we configure the ports connecting to the PCs to the corresponding VLANs. Once the VLAN information is configured on the other switches, the faculty member using PC1 would be able to communicate with PC4 because they are on the same VLANs. If the faculty member wanted to send something to PC5 which is assigned to VLAN 30, then the services of a router would be required. VLANs help reduce excessive broadcast traffic and implement access and security policies between groups of users. Types of Internet connections: dial-up, ISDN, broadband. When connecting to the Internet or other networks, different technologies are used depending on the speed, availability, and use case. Below is a discussion of a few common connection types. Analog telephone access, dial-up. Dial-up is one of the earliest forms of Internet access. It uses an analog modem that connects to the telephone line to call another modem and establish a connection. The data transfer rate is very slow compared to modern standards, and the connection blocks the phone line while in use. Though outdated today, it laid the foundation for Internet connectivity. ISDN, Integrated Services Digital Network. ISDN is a digital improvement over traditional dial-up. It offers higher bandwidth and can carry voice, video, and data over the same line. ISDN connections are more reliable and faster than analog dial-up and were commonly used before broadband became widely available. Broadband. Broadband is a high-speed internet connection that uses a wide range of frequencies to transmit multiple signals simultaneously. It allows for much faster data transfer rates and supports activities like streaming, gaming, and video conferencing. Technologies under broadband include DSL, cable, fiber optics, and more. Unlike dial-up, broadband connections are always on and do not interrupt phone services. Each of these technologies represents different stages in the evolution of Internet access, moving from slow and basic to fast and high-capacity connections. Internet technologies, DSL, cable, and fiber. Modern Internet connections rely on different technologies to deliver fast and reliable service to users. Below is a discussion of three commonly used connection types: DSL, cable, and fiber. DSL, Digital Subscriber Line. DSL is an always-on Internet technology that uses existing telephone lines to deliver Internet service. It operates by sending voice and data on separate frequencies, so users can talk on the phone while being online. A filter is required on the phone line to prevent interference. There is also a faster version called VDSL, Very High Speed DSL, symmetric VDSL can offer up to 26 megabits per second for both upload and download. Asymmetric VDSL can provide up to 52 megabits per second download and 6 megabits per second upload. VDSL2 can support speeds up to 100 megabits per second in both directions, depending on distance from the provider. Cable Internet. Cable Internet uses a cable modem connected to the same coaxial cable network used for cable TV. It provides higher speeds than DSL and is widely available. However, the bandwidth is shared among multiple users in the area, which can lead to slower speeds during peak usage times. Fiber optic internet. Fiber provides the highest bandwidth and fastest speeds among all internet technologies. It is commonly used in backbone networks, large enterprises, data centers, modern residential services. There are two common fiber deployment methods: FTTC, fiber to the curb. Fiber is extended close to the user's home, then transitions to coaxial cable, HFC network, for the final connection. FTTP, fiber to the premises. Fiber runs directly to the customer's building, offering the fastest and most stable connection. Each of these technologies has different benefits and limitations depending on location, infrastructure, and user needs. Fiber is generally the fastest, while DSL and cable remain widely used due to existing networks. We'll discuss the remaining topics in the next lecture. Thanks for watching. Subscribe our channel Network Professionals for more informative videos.